we do is we look at Scrumban. That is, we take from Scrum the regular cadences, the transparency, problem slicing, reviews, and stand-ups, all the things that work very, very well for teams that are of any type, delivering any kind of project and working on any kind of problem. We then borrow from Scrumban the key elements that are very valuable in this situation. Not estimating, not having an end of sprint commitment. If a data scientist is unable to predict what they're going to do in 2 or 3 rounds of experiments, they're not able to predict and make a commitment to what they're going to do for the end of a sprint. So we drop that element completely. We still maintain regular progress. We still maintain the capacity to review work when it's done. We also allow for the opportunity to present work in progress as well. So a data scientist is then in a position where they're not making a commitment for what they will get done, but they are saying, I will show you when it's done, and I will show you my progress through the problem on a regular basis so you can see the value that I'm releasing, even if it's not necessarily a completely done thing. So how do we go about doing that? First off, we split the teams. We have one data science team and one ML engineering team. Both teams are working on separate parts of the problem. The scientists are working on the model. The engineers are building the APIs, the back-end data storage, front-end systems, and then any ancillary features that are needed. If you run both teams together, you can lose a lot of that transparency and a lot of that understanding. So splitting them out will really, really help them to focus on what they're doing. You'll also notice that by splitting the teams, you can use Scrumban for the data scientists and maintain Scrum for the engineers. So we can use 2 different ways of working across the same project, which allows 2 different teams that operate in fundamentally 2 different ways to continue to operate in 2 different ways and not compel them to work the same way. It's also very, very important that we maintain a high level of alignment between the 2 teams. We'll talk about how we do that in a moment. By running 2 teams, you actually break their dependence on each other as well. They're able to operate independently, they're able to deliver independently. But that alignment remains absolutely critical. And we do that by having a one-team mentality. That is, we have one stand-up and everyone comes to it. The data scientists talk initially and then the engineers talk afterwards, each with their own board, each talking about the work that they are doing, but each listening to each other about the degree of progress they are making, because one feeds into the other. And having those conversations, keeping them broad and open, means the 2 teams can support each other and head off any problems before they really occur. This also means that both teams have the same cadence, they share a review, they share a PO, and they regularly collaborate together. So for all intents and purposes, despite the fact we split the teams into 2 different teams and they operate in 2 different ways, there is in fact one team. They just have to have different boards and different methods. And this is critically important. This is how we maintain that tight alignment, but that loose coupling. In the same way as before, when we're talking about established data science projects, we will see that engineers have a higher rate of delivery than the scientists. And this means that their delivery, the engineer's delivery, can be impacted by the scientist's rate of progression. So we need a way to get around that. And this is it. What we do is we set up very early on an agreement on how the data model will work. That is, the data scientists say, this is the type of data we're going to be delivering to you. This is its form and its format. The engineers understand the data that's going to be provided to them, and they're able to build a system which is ready to receive that data. We're then able to set up a considered fake data approach. We know the data that's going to be provided. We know what form and format it's going to be, so we can go out and we can create something that matches that data structure. Obviously, as I said before, we have to ensure the data is appropriate and it represents the real world data as closely as it is physically possible. But by having this approach, what we are able to do is separate the two teams and break their dependencies on each other. The data scientists know the end game in terms of what they're delivering, and they can build their data science model to follow that. The engineers know the data they're going to be receiving, and they can build a system that is able to receive that. And in this way, we decouple both the teams. Somebody will recognize this approach. It's the API approach we are seeing a lot more in engineering projects these days. It's just that same approach applied to a data science situation.